So let's start with our hello world for Java, and I'm talking about Java programming. So what I'm going to do here is I'll show you where to find this lecture stuff. I'm not a huge PowerPoint fan. I'm becoming less and less of one as I continue here. So I like to just talk and show you stuff at a prompt and show you examples and stuff, but then some people like PowerPoint, they like reading. So I'm going to kind of try and do a hybrid here, but I'm going to show you where to find this stuff that I'm going over right now. If you go into Object-Oriented Programming with Java, and you come down to the PowerPoint lectures, I'm going over the first couple of them here. So these are the lectures here that are going to go through everything. In fact, the number 1 is the first one I'm going to go over, number 2, number 3, kind of in that sequence. You'll be able to find it. I'm also going to show you the PowerPoint, so you don't have to download anything right now. This is for future reference, like, hey, that was an example, and where is that PowerPoint? These are where the PowerPoints are. There's also a directory in here with example files. So if I go back, hit on course materials, here I'll go back from the beginning. Object-Oriented Programming with Java, click on, this is the course materials section here, and I come back and I look at lecture examples. I'm starting out on the bottom here with sample 1 classes. This one I would highly recommend downloading right now. So go ahead and save that one to your desktop. I save it to the desktop. Actually, I have it saved right here, so I saved it again. But if I save it again and double click on it, I get this. I get this full folder. If I open up the folder, I'm going to get hello, which I'm going to talk about first. Employee, pencil. This is what the folder looks like inside. These are single Java files, and I'm going to start talking about Java and how to program in it. So I'm going to take this off because I already have it downloaded. So if I go, this is the first lecture here, so I'm going to open this up here as well. So this is the one that was called Lecture 1. I'm not loading it in PowerPoint, I'm putting it in preview. So I'm going to go like this through it. And I'm sort of using this as a kind of a memory aid to keep me on schedule. If there is a concept that I have brushed over that you want some more information on, please do feel free to interrupt me. You're not being rude. You're actually helping me help you. So if you are loading this up, what I'm going to start doing right now is introduce object-oriented programming in terms of the concept. So in object-oriented programming, obviously everything is an object. In Java, everything is stored in a file called .java. The .java file turns into a .class file. We see that if you've downloaded that file I recommended that you download, take it and copy it somewhere where you can easily get to it from a command prompt. So take it and, so let's see. We have, let me minimize this for a second here. It should be called the first one is called WJP-simple. I've taken it and I've copied it into my home directory. So open up your home directory here, and I renamed them JP for Java Programming -simple. So this is the one here. And then simple 2. So I put them in the home directory. So I can actually go to my command prompt right now. And if you're new to Linux or Unix and you're not familiar with command prompt, ls is the Linux command for this. This is equivalent to dir if you're doing a dir in DOS. Doesn't really matter. Instructions are the same regardless of what platform you're on. I'm going to change the directory to jp.simple1. And I can see these are the files that I'm looking at. These are the files that are going along with Lecture 1, which is the PowerPoint that I have up right now. So the first Hello World program, I just did a cat on it so you can see this here. Cat is basically like type it out. So I'll teach you Linux here at the same time if you're not familiar. Because Mac OS X is based on BSD Linux, so Linux commands work on it. If you don't like that technique and it's sitting on your desktop right now, I highly recommend this. Come over to this where it says Hello Java and open it with Text Wrangler. If if you haven't got that installed, or text edit also works. You get this. This is why I like Text Wrangler, by the way. It color codes everything for me. And you can also change the type, so I can go into Window and change the fonts. Actually, let me do that real quick. If I can remember how to do that. Actually, here I can do this. There we go. Now it's bigger. All right, so those people who have this, it's not a bad idea to open up. This is the one called hello.java. Open up that file. Actually, I don't want to do that. I'll show it to you on the command prompt. And so this is the basic structure of, hello world, which is it's the first program everybody writes in any programming language when you start learning it. Everything in Java is in a .java file, and it's all text compatible files. So if I wanted to compile this program as an example, I can type in javac space, and then I type in hello.java. And I don't get anything, it just comes back to the prompt. You can try this as well if you'd like, and you would have compiled your first program, although we haven't written a program yet, you would have compiled one. And now we have to see, how are we going to run this thing? Well, I can go like this for Linux, which is going to tell me my current directory. It's a dot and a // and then I type in hello, and it's going to tell me that it doesn't exist. Let's see. We have a hello class right here. Oops, I didn't type in Java space. Hold on one second. No main. What's wrong here? Exception. No class. Oh, let's take a look at hello Java. Oops. I believe my compiler is not configured correctly. Yeah, I didn't add it, so it's not in my class path. My Java, well, this is because I did something else with it. But long story short, it wasn't finding the file that I was trying to run because it wasn't part of my class path. If you have it in a DOS system, I believe it would probably actually work because you don't have to worry about the class path, and the class path is set free automatically when you put the bin directory into the path. But in a Mac system, I'm not really going to do very much command line prompt compiling, so it's not really going to be that big of an issue for me. But if, for example, you wanted to compile something on a command prompt, that's what the javac command is for. So all Java programs get written in .java files. To compile the program, you type in javac space, and then the name of the file, as this particular case is hello.java. And it comes through and it compiles it for you, and then to run the program, if your class path is set correctly, then you're typing in java space, the directory path where the file executable is located, and the executable is in a .class file, by the way. Then you type in hello, but you don't have to do the .class. You just type in the name of the file. And if my class paths were set correctly and everything was working on this computer correctly, then it would actually run the program for me. Kind of the hard way of doing it, which is why we went through the thing of installing Eclipse. And Eclipse will actually set your class path for you automatically. So if I exit out of this command prompt window and I open up Eclipse, as an example, and I drag the hello.java file into Eclipse, I have a much better working environment. I have something that's really GUI and that allows me to command, to compile and run it right there. So Eclipse is now opened up, and I'm going to make the window a little bit smaller. A couple of options I can do. I'm going to import the first time to show you how to do it. You can also drag and drop and stick stuff in as well. So I go File, and I say Imports. So in the File menu of Eclipse, this is the same if you're in Windows or on the Mac. Select Imports, and then it's going to say Existing Android Code into Workspace. If it doesn't say that, it might look like this. Or you might have to be able to go, general as an example. And this is not Android code. This is going to be Java code. So I'm going to go hit the general here. And it says existing projects into workspace, file system. So I can select options for this. This has got, yours may not have Git. It does have Git. So this is how you would actually import the Git if you had a Git file or Git project that you were installing in, project from Git right here. So it is installed by default actually. Then I can say, well, file system, how's that? And then I click on browse as an example, and I can find, let's say for example it's on the desktop and it's in hello. Okay, so we can just take hello, put it in here. I just basically selected something from the desktop, but I don't want that. Let me go into JP Simple. Here we go. And then in here I can select hello.java as an example. And then I can go, do I want to copy it in? Do I want to, so I'm going to say this, or I could just say select all as an example. And then I can copy it in, or I can use the original file in. I can also, and I'm basically showing you how to get stuff into Eclipse. We'll just create a default project in a few minutes, but you don't have to do any of this. I can also take and drag stuff in if I have an open project. The problem here is I don't have an open project. So let's write hello world. And basically I've shown you what hello world looks like from a file perspective. Let's write hello world by looking at the original and creating a new Java project so we can sort of see how it's done. So go ahead and open up Eclipse if it's not opened up already. Yes? I'm sorry, one more time? Oh, that's fine. Because I'm just going to demo this a little bit, then we're going to have lunch and you're going to finish the download, hopefully. And I'm going to be talking through this so you can probably catch up. Is the internet working okay? Very, very slow. Anybody else having problems with the internet access? You might want to try this one that says meetup-itu next to it. That's the only one working? Are you serious? Oh, look at that. I don't have an internet access right now. Has it been, actually this is good feedback because then I can tell our IT guys, has it been going up and down? Or it's just not working? Not connected. So I see that I'm not connected actually right now. And I'm on ITU. So, okay, well I'll keep that in mind. And how about this? I'll wait until after lunch when you have Eclipse installed because I would hate for people to miss out on this. And I'll switch gears a little bit and talk about object orientation and writing hello world. So we will wait because we're having problems downloading stuff. I don't want to talk too far ahead. Okay. Object orientation. So here we go. Everyone can follow along with this. So as we saw before, we had a .java file. When you compile the .java file, it turns into a .class file. Well, what is a .class file? It's a class. In other languages, you can program in C++ as an example without never having created a class before. It's called a procedural language, where you can create functions and you call functions from other functions. And you basically follow through the source code from the start to the end, and it's really a different style of programming. In Java, you're forced to use object orientation, so it's not a bad idea to be familiar with what the concepts are so that you can apply it. Object orientation is extremely simple. It just means we have a starting object, and our starting object makes instances of other objects, and all the objects work together to formulate the project or to formulate the program. So we represent the entire world in terms of objects. And so the first example I'm going to show you, I probably won't go through the source code until after lunch, but first example is going to be a pencil. And so we have a main program that's going to make instances of pencils. And then each one of the instances of pencils can have its own color, its own length, its own characteristics associated with it. And then we use those pencils to perform the activity that we want in the class. Basically what we're doing is taking the functionality of the program, breaking it out into objects. You can think of an object like an entity or as a component. So people, type A people that like to create lists or that like to compartmentalize everything love object orientation because it lends itself very well to list making. So one of the first things you do is when you think about, I want to write this application, and this application is going to perform this activity, well, break it out. So make a list of all the different activities and bundle stuff together and say, well, you know what, you're going to have pencils, we're going to have pens, we're going to have erasers, we're going to have paper. And then make an object that represents each one of those different items in the list. And then we create what's called a main driver program, which is the old main in procedural programming. And then we make instances of all those little list items. And that's essentially our program. And we run the program, and every time it runs, it sort of runs dynamically. We don't know exactly how many pencils and pens, and it depends on what the user selects. So this style of programming lends itself quite well to event-driven programming. Which is, basically what happens with Android mobile devices and applications that we write nowadays. So the unit is the procedural program, which is the function. We have functions in object orientation, but they're called methods. So there's 3 components, and usually I have a whiteboard that I can write this on, but perhaps let me just talk ahead here without writing it. Imagine an object. You can take some notes on your own if you want. There's 3 components to the object. There's identity, state, and behaviors. This is the same for Objective-C, same for C++. Any object-oriented language works the same way. So the object identity is its function. It's where it ended up on that list that I gave you. It's a pencil. It's a pen. It's an eraser. And so the identity identifies what the object's going to be used for, what it's going to represent. The states are what color ink is in the pen. Is it a black pen, or is it a blue pen, or a green pen? All the different states associated with the color, ink color. May also be, how much ink is in the pen, something like that. And then we have the behaviors. And the behaviors might be, what does a pen do? It writes. Open the pen, close the pen, like put the cap on the pen. And use the pen for some function, which is going to be a method or a behavior. So we break those objects that we've identified out into those 3 sections, and then we write the source code that matches those 3 sections, which is sort of like, it's a very it's a nice methodology, and it's a very systematic way of designing a program, which makes it more reliable because then you're not going to leave something out, or you're not going to. Hopefully, and you're going to have objects that make sense. And then what we end up doing in object orientation is we build other objects from the base object. So if, let's say, for example, we have a pen, and the concept of a pen exists, but we want to make a highlighter. Well, it's kind of a form of a pen. So we make a new class highlighter, extend it from pen, keep the ink color, keep the on and off state, or open and close state. Keep all the behaviors of a pen, because we still want it to write, and we still want to be able to do stuff with the pen, but then add other stuff to it. And the other stuff would be stuff that would be related to a highlighter pen, which is a special kind of pen. So one of the things you have to do initially when you start designing your program is think about, not only which objects are going to exist in this program, but which objects are related to other objects. And then we're going to build a hierarchy, essentially. So a pen is now a highlighter pen, and then we can have, different kinds of erasers that are all of eraser, or different types of anything that are specializations. So they call this specializations through the hierarchy. Another example that might make more sense is humans. So we are all humans, and some humans are students, some humans are not students, some humans are, let's say for example, employees at a company. But so you have a base object human, and then you have another object employee, and then you might have another object on top of the employee that might be HR employee, marketing employee. So the different types of employees that are built on top of that. And then you might have more specializations that happen with that. So if I was building an HR application, I'd start with a human. Or if I was building an education application, I'd start with a student. And then I would give the students properties, and I'd give them behaviors. And then I'd build other objects that built on top of students that gave them more properties and more behaviors and stuff. And then kept building that and building that and building that. That is object orientation. It's a different way of thinking. than when you learned BASIC or when you learned C. And it says, here's main, and you started main, and you declare this and you declare that. Did you have a question? I thought I saw a hand. No? Okay, good. Just a stretch. Okay, good. Different way of thinking, which is the differences between this, basically covering this slide here, talking about procedural versus object orientation. So instead of looking at the function and the procedure, we're looking at the object-oriented behavior. So the concept of the class and the object, as I mentioned before, Java is truly object-oriented. You can't program in any other way. In fact, when you program Hello World, it is a class. So everything is created in a .java file. When it's compiled, it turns into a .class file. If you've ever done any web development with applets or with code that was created in Java, you know that you have to upload the .class file. And the .class file is the file, right? Well, it's partly binary and partly executable kind of code. Works with the JVM, which is why we have to go through this install the JVM as well as the JRE. Excuse me, the JRE is the JVM, runtime environment, as well as the JDK, which is the development tools. So we take one JDK, if you're not familiar with this concept at all, JRE, Java runtime environment, and it works in a web browser. And then we have a Java runtime environment that works for your computer, for your Mac, for your Windows, for your Linux. And we have one .class file. And the one .class file that you're compiling runs on all of those JREs, which is why people like Java. So you write the program once, one set of source code. You run it on all those different JREs. Obviously, the platform has to have the JRE installed on it, which means you have to, you essentially have to make sure that the consumer has set up their environment correctly. But normally, your web browser, if you've ever, installed a brand new computer, or installed a browser, a brand new computer, first thing you have to do within the first week or so is say, hey, you know what, download the JVM, okay, download this, download that, download this plugin, download that plugin. Those are the plugins, so the JRE is usually a plugin on a browser, which makes Java browse supported. It also makes it application supported, so it runs on a Mac. It also makes it so it runs on a BlackBerry, an Android phone, and on Java platforms. Anything that has a JRE on it, your Hello World can run on it. So the class refers to the blueprint. It defines the variables, the methods, and the object support, all the things that are going to be associated with it. The object is an instance of a class. So we create a bunch of classes. We compile them so we get .classes. And then in another program, in a main program, we make instances of those classes. And I'm going to show you the format for doing that and everything as we go through the code. But starting at a basic level, the object is the instance of the class. So when people talk about classes and they talk about objects, it's really talking about the same thing. But one is the source code. When you're talking about classes, you're talking about the source code, the implementation. And you're talking about the object, you're talking about the runtime environment when the code is running. That's really the object behavior. So each object has a class which defines its behaviors and also its data. So there's three kinds of members. So these are sort of like the identity, state, and behavior I gave you in terms of three types of characteristics of an object. So they come in many different forms, and if you read about 5 different textbooks, you'll see about 5 different definitions for each one of these terms. The first one here is the fields. Well, fields are data. So think of this as, let me see, we have fields, data, data members, variables. That's another word for it. So if you've taken any programming classes before in any language, you know about variables. And so unfortunately, I'm going to start at the variable level because some people haven't never taken a programming course before. A variable saves data. A variable in C, you go integer I, semicolon, I is equal to 1. Same thing in Java. So we have built-in data types, and then we have object data types. The built-in data types that you get in Java are very similar to C. We have, well, they call them primitives. So we have integer, float, double, string. Actually, we have more variety, I think, in Java than we have in C++. This is when a DEDL and DEDL text would come in handy. Because in the first chapter of any textbook on programming, they say, these are variables. Variables have 2 components. They have a data type and a name that identifies the variable. In object orientation, they're called fields. Maybe they're called data variables. In C++, they call them data members because they're members of the class. Right now, we'll just call them data, or we'll just call them variables. And when we start seeing the code, this is going to make more sense to you. We also have another component of the class, and it's called a method. And that's where people go, oh, a method, I don't know what that is, or a message. So some languages, they call them messages, some call them methods, some call them behaviors, some call them functions. A method is a function, if you're familiar with a function. If you're not familiar with a function, well, a function is a way of taking a ton of code statements and putting it all under one name. So you write a function, and I'll show you how to do that. You put the code in there, and then when you want to run that code, you just call the function. It makes it easier so that you can run the code over and over and over again without having to write it again and again. You just make a function call, and it executes all that code for you, and you don't have to, it makes your code easier to read. The concept's been around since the beginning of C. It's incorporated in object orientation inside of the class. So we create a class, just like that .java file I briefly showed you, and we put all this stuff inside of it. So that when we make an instance of it, we have access to the data and we have access to the functions. Think of this kind of like for people who are familiar with procedural language, think of this like a program inside of a program. You have like all these little programs, and you're putting them all inside of another program. It's all the same concept all over again. So the methods here have the executable code of the class built in from the statements that are given to it. It allows you to manipulate and change the status of the object, or to access the data that's inside of the object. So objects have this little protective mechanism to them. We have access, they call them access modifiers. Well, okay, they're methods, well, they're ways of getting at and protecting the data. And just to make this clearer, if you're familiar with this concept, it's public, private, and protected. For Java, what we're going to talk about today is the concept of public versus private. So anything that's public is available to anybody. It's public. It's like the internet. You know? Anything that's private is exclusive rights. You have to ask me, and I'll tell you. It's private. So we built the mechanism into the class. By default, we make the data private because we don't want anyone changing the data that's associated with this class until we give them the right to do it. So here's an example. If we want to change the ink in our pen, we want to make sure we're changing it to the right color. We're picking a color that exists or something. So we're going to make the data members private and the member functions public, and so that we can change the data easily without having to worry about it. The wrong color or something like that being selected. If we make it all public, then we can change the color of that pen any way we want without using the method, without using the function to do it. We just change the data. So I'm going to go through examples of all of this stuff actually, as soon as we start looking at the source code. We can also nest classes, and we can also nest interfaces inside of classes, which is an interesting concept. So here's a sample class, and I believe this is very similar to Hello World. And we'll see this work live after lunch. Everyone's got the tools installed, and I see that my internet is still down, which is kind of interesting. It's funny because it says it's up here, it just doesn't do it here. Anyway, in approximately a half hour, we'll take a break, and I'll see what's going on with it. So, unless you guys want to break now, it's totally up to you. How many people need a break right now? Just one person? 2 people? 3 people? Actually, if we do this, then I can go for another hour after I break. Let's take a quick break, because people have been sitting here since 9 o'clock, and I just realized that's my problem. You have to tell me you need a break. I start at 9 and I go until you guys tell me you need a break. It'll be reasonable, I think, at this point to take a break. It's been 2 hours. Let's take a bathroom break. And then let me check on the internet, and then I can see, hopefully get this working for us. Okay, let's resume where I left off. And I was looking at a sample class. And so I was explaining to you the concepts of the object and the 3 components that are associated with it: identity, state, and behaviors. We have other people who categorize it differently, so that's just one way of thinking about it. In terms of the sample class, this is an example of a pencil. If I had another class and I wanted to call it pen, I'd use the same format. And one thing to note here is the format. So we have the keyword class that is used, along with the name of the class, which is called pencil. And in this particular pencil class, we have 1, 2, 3 data members, or variables, if you want to call them that. And then we have 2 methods, or functions, if you want to call it that. And there's a couple of things in here to note. We have this keyword public, as I mentioned before. We can actually put the keyword public out here, too, and say public class pencil. But this one doesn't have that. And we can actually take public away. If we take public away, it's assumed to be private. So we've made it public, which is the reason why we're using the keyword public here. Otherwise, it would be private. If you want to see this copy of it out in a text file, it is in the JP sample 1, and it is the one that's called pencil here. So if I open it up in Text Wrangler, as an example, I see the same code. And you can see this is what we're going to be compiling and running after the lunch break when everybody's up to speed. So you don't actually have to worry about typing this into a file. All of the lecture examples are going to be in that first downloaded file. And if you are having problems downloading that information, it is here. I had to point this out to a couple people, so I thought maybe I'd just say it again. Which is why I kind of like breaks, because then I know where people get lost and what's going on out there. I went into the object-oriented programming and Java directory, and I'm going into here where it says lecture examples. And this weekend, we're covering these 3, classes, inheritance, and interfaces. So if you haven't downloaded these yet, as soon as the lunch break's over with, we're going to start using the source code. These are the examples that are in the lectures. And they're zip files, so you just unzip them. Don't worry about where you put them at this point. You can just leave them on the desktop because we're going to need to import them into projects. Okay, so here's our sample class pencil. And as you see, we have, these are data. This is variables. So if you've never taken a programming language before, the syntax is you put the data type and then the name of the variable. And here we have integer length. And here we have float diameter and string color. In Java, string is a built-in data type. If you're not familiar with Java, if you're familiar with C++ as an example, you know string is an object, and you have to include string.h. And if you are a C programmer, you're familiar with this, all this, include that, all the namespace and all the other stuff. Don't need any of that stuff in Java. The JVM is running all of the libraries that we need. Has all that support built into it, so it's a little easier, believe it or not. It is easier than C++, easier than C. If we will see in the future, we can import, and that's a different syntax that we put above the class. So what do we have here? We have 1, 2, 3 variables, 3 data members, and here we use quotation marks because it is a string. If it was a character, it would be a single quote, and we would have character char as the data type for this variable. And then we know these are methods here. Well, this is not a method. This is another piece of data. We have one method in here. Here's a method. A method is a function. And I'm going to talk about methods a little bit more in detail, but just to orient you to the concept, it's what's going to be performing the behaviors for us, which is why they call them behaviors. And this behavior here is setting color to equal to new color. And new color is coming in from a parameter that we're passing to the method, or to the function call. I'm going this slow because I know some people may not have been exposed to the method or the function concept. And remember, I said before, this holds a lot of code that we're going to use over and over and over again, hopefully. This one here, although it's indented and it's shown along with the method, isn't a method. It's actually another piece of data because it's really long, which comes from integer, because integers have longs and shorts, or you can just say int. But it's a long, which is another data type, space, next ID, and we're going to have it equal to 0. But we have this word static in front of it. I'm going to go wait until after lunch to talk about static. But it makes the difference between, is this an instance variable, or is this a class variable? So as I mentioned before, we create classes, and then we create objects from these classes, and the objects created when we make instances. And I'm drilling through the vocabulary because this is what you need to know in order to understand the concepts. After a while you go, yeah, this is an instance, and then you'll start using those words too, hopefully. But we make an instance of the class, turns into the object. Each one of those instances usually has its own values associated with the data. And it all has usually the same set of methods or behaviors that are associated with it. So you get a copy of all of this for each one of the instances that you create. Now, what if you want one copy for all of the instances together? That's a class level variable versus an instance level variable. So from a class perspective, next ID is going to give us a number that's going to keep a running total of all of the IDs that are generated for all of the instances that we've created. Here's an example, students. And you're going to create student objects. And you're going to have student A, student B, student C. And each student's going to have a student ID. If you keep a class level variable, then they can all share the same counting system. So you can have student 1, student 2, student 3. And so all of the instances are all sharing the same variable that's kept amongst all of the instances at the class level, which means it's part of the class implementation, not part of the instance. Which means you can keep a running total. So people do this for check registries as an example. So each new instance doesn't start out with 0. It starts out with, what was the last one? It looks at some shared value that's shared among all of these other instances and uses it and increments it and then assigns it to something, which is what this is doing in this particular case. These are just pencil IDs, kind of like student IDs. So usually you don't see this until you write, like, intermediate level programs where you start using classes versus instance methods and class versus instance variables and things. But it's nice to know there's two different options. So for this particular, well, for today we're going to focus on instance everything, which means each instance of this object holds its own set of values for all of its variables and all of its data. But that's what this keyword static actually means. And then here we have public, which means it's going to be available from the public. What's the public? That's main. See, nothing here is running a program. This is just a creation of an object. So in main, we're going to make a new instance of this object. And then we can run methods on the object. And when we run methods on the object, we're going to use like this little dot notation. I'll explain that in a few minutes. And then we can manipulate the object, let it do what we want it to do, and everything works out great, hopefully. So that's why this word public is in here. All of your methods are going to be public. Normally, all of your data is going to be private. So this is just put in for illustrative purposes to show you that it can be private if you want it to be private. But here I have void set color, and I'm going to pass a string to it, and the color is going to be equal to the new color. So that's basically, yeah. And this color here is this color up here. And this new color here is this thing that I'm going to pass to it. I'll show you the syntax part, and it'll make a lot more sense when you start seeing this live as well. But that's what that's about. So the field declarations, in order to define a variable or a field, we have the type, the name followed by the field name, and optionally an initialization clause to initialize it. This is the initialization, by the way. So to declare a variable, I would say integer length. To initialize it, I'd say length is equal to 1. I'm initializing a starting value for it. It's a standard syntax you hear in C development as well. Here we have a declaration and an initialization all into one. String color, color is equal to red, all into one. So, it's like when you read it and it says, declare a variable called integer, called my integer. Okay, that's integer, my integer. Initialize it with the value of 1. Well, my integer equals 1. And basically you're following along. So what ends up happening is you start reading tutorials or instructions, and it'll say, declare 3 variables of type float. And then okay, that's float A, float B, float C, or something. So, basic terminology. We also have primitive data types versus object references. This is an object reference. When we compile this code, it turns into an object. And how do we compile this code? Well, we cut and paste this here. We stick it into a text file. We have to call the file by the name of the class that we have defined in there. So this file would be called pencil with a capital P .java. And then when we compile it, it turns into pencil with a capital P .class. If we call it something else, Java's going to complain. Or if we call it P with a lowercase p and it's an uppercase P in the file, Java's going to complain. It's case sensitive. So we have to make sure that we use, and it's not a bad practice to get into, use capital letters for all of your object references. You know why? Because all of the primitives are all lowercase. That's how you can tell a primitive from an object reference, is the case that the name starts out with. So final, static, character, byte, short, no capital letters in here. They're all lowercase, which means they're all primitives. What's primitive? It's built in. It's made by the designers of the compiler. You can't change them, you can't do anything with them, you just use them. And they used to say, well, you take primitives and you create object references from the primitives. Yeah, that's what you're sticking inside of the object references. But in anybody's compiler that they've just installed, there is no such thing as a pencil.java class in there. That's something you made. It's an object reference that you created. And you know it because it has a capital P in there, hopefully. So when you start writing source code and you start looking at it, you go, oh, is that a capital or is it a lower? If you didn't make it yourself, it's lower. So, and if you made it yourself, it should be capital. Or somebody else made it for you and you're including it, then it's capital. So as long as you get kind of familiar with that as you program through, you'll be able to instantly tell if it's supposed to be lower or upper. Because usually when people start writing source code at the beginning, you know, it's like capital S in string or lower. Actually, it's a good question. Ask anyone, is it a capital S in the word string or is it a lowercase s? Well, in C++ it's capital. Same rules apply. But string is an added-on object reference. It's not a primitive. So, well, what difference would that make for you? No difference, really. So, here's those modifiers I was talking about before. They're called field modifiers. They're also called method modifiers. Access control modifiers is another way of putting it. Private, package, protected, and public. So in Java, we have this thing called package. Actually, we have a couple of different concepts in Java that we don't have in any other language. We have jar files, we have war files, we have packages, we have all sorts of different things. What does that do? Nothing elaborate. It's like pkzip in most cases. That's what a jar file is actually. In fact, you can use zip utilities to unzip jars. In fact, if you've downloaded it and you look in your Java directory, you see jar this, jar, you know, .jar all over the place. It's just, you open up the jar, you see a bunch of little files, they're .class files. So a lot of people do it themselves. This is not packaging, by the way. This is compressing all into one file. Because if, let's say you're building this huge application and every single one of your classes is in its own separate little file and you have maybe 30 or 40 of these little .class files, it's hard to keep track of all of them. And then if you forget one of them, the program's not going to work. You have to have all of them. So people like to compress them all together and build a jar out of it. So a WAR is a networked internet web archive. Jar is non-web traditionally, but you can use them interchangeably actually. And they're used for different purposes. And it's basically used to compress, just like pkzip compresses, put everything all into one file. Makes it easier for uploading, downloading, for distributing your application. Then we have a package. A package is like a directory structure. It's like your file, my file manager in Windows. It's everything in there. You have my documents, my pictures, applications. Actually, it's the same concept that you get in a file structure on a Mac. It's really called a package in terms of the reference. You're putting something in a folder, you're packaging it with other things that belong to it in the same folder. Then you import the package and you get the current folder and everything below it, or you get the current folder and everything above it, or you get certain parts of the folder, the directory structure, and you import it instead of including, if you're familiar with that terminology, to make it accessible. And then you save things in the package, which is kind of like Windows. In fact, if you remember the install we did, earlier today, when we had to update the environment variables to include the bin directory, it's kind of like updating the environment to include a package with the bin, because it's not accessible outside of bin unless we put it into the environment, make it available. So when we import packages in Java, we're doing the exact same thing. We're loading it into the environment to say, hey, we have some stuff we're using in this directory here. The directory looks a little different. We have a name, and then we have a little asterisk thing, and I'll show you that syntax as well. That's basically saying, hey, use this package. import this in here. We can put things into a package. So as long as we just put package on the top, we can save our code into the structure. We can pull things out of the structure, and it keeps things organized. Because what we have is a bunch of little files. If we put them all into one folder, it makes it hard to organize that. With those concepts I just discussed, we have different access methods associated with it. Private. So private members I talked about a few minutes ago are accessible only inside of the class itself, not into public. So we made them public so we can access them out into a main program. We'll see that, and we'll see an example of what happens when we change it to private when I go through the source code. Package members are accessible in classes in the same package and in the class itself. But if you make the access modifier, same way where we saw keyword public, we can put the keyword package in there. It means it's only available in there. So we're looking at modifying the visibility and the usability. If it's private, it's only used inside the class. Public can be used anywhere. Package inside the same package. Protected, it's private to the normal public, which is main, but it's accessible to inherited classes. Same thing in C++, actually. So protected members are accessible in classes in the same package and in subclasses of the same class and in the class itself. We'll get into protected when we start looking at inheritance, probably not till tomorrow, actually. So here we have an example of what happens when we try to do something. We took the same example that we looked at before, and we changed the public to private. So now we see private float price over here. And then this is the main program, but this is actually a twofold example that I want to spend a little bit more time on outside of just this error message. So we have two files. We have one called pencil.java, and we have another file called createpencil.java. And inside of here, we're looking at, well, what are we looking at here? We got float price, and float price is private now, which means we can't do this, p1.price. Well, where does p1 come from? Well, that's an interesting thing. So here's the trick. Right above that little error in the code, this is a nice piece of code that everyone should be familiar with. Hopefully this is not an error. This is how you make a new instance of the object. So we have a pencil.java. Let's say we also have a pen.java, and we have an eraser.java, and all these other items, and they're all stored in different files. In create pencil, that's where we take all of these items and we put them together and we start using them. This is called the main driver program because it includes main. Here's void main. Main is a function from functional programming that kind of incorporated it, made its way into object orientation, actually. We call it the driver because it's driving the program. This is really the program. These are the objects that we're going to put inside of the program. So pencil P1, this is like saying integer I. It's a declaration. So instead of saying, integer I or integer P1, P1 is equal to 1 because we know we can make initializations of integers to integer data types. So the data types have to match. So if we want to create this pencil here and initialize it, we make it equal to new pencil. Right now, just write that down, memorize that format. You can create any instances of any objects that you want using that format. Easiest format to remember because it's pencil and pencil, it matches. So you can actually do the same thing with integer. You can go integer P1 is equal to new int. Anyway, it's basically a way of declaring and initializing the space. So what do we get with this new? Don't really need to know this, but if you want to, as a little bit of trivia, this is called dynamic memory allocation. In C++, if you're familiar with that, you have new and delete. In Java, you just have new. There's no delete. Because Java runs in its own JVM, and it does its own garbage collection. So we can go new, 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 all we want. We never have to delete anything. Also, if you're familiar with C++, because some of you have taken a C++ class and now you're going to Java, or you may have taken a C++ a long time ago, who knows. We have constructors, copy constructors, and deconstructors. 3 things that happen automatically when an object behavior occurs or object environment behavior occurs. In Java, we just have 1 constructor. No need for a destructor because there's never a need to run delete on anything. And then there's no need for a copy constructor because there's never a need to copy memory from one location to another. It's done automatically for us. The JVM is doing all that stuff for us. This is what makes Java easier than C++, especially when it comes with dynamic memory. This, if you're not familiar with C++, but you're familiar with C, that's equivalent to allocating space to a pointer. P1 is working like a pointer. So in C++ and C, everything is a value, not a reference, and everything is done statically. If you're not familiar with that word, don't worry about it. If you're a computer science major, you probably know what I'm talking about. In Java, everything is done dynamically, and everything is a reference, not a value. So a value versus a reference, don't really need to know this, but a reference is referencing memory. Values are referencing data values. So integer I is a value. It's not a reference. Pencil P1 is an object reference. The way we know the difference in Java is that this is an object, not a primitive. Yes?
Pencil class, where physically it should be located?
In the same directory or in the same package. Because we haven't specified any package information here, these two have to be in the same directory. After lunch, we're going to compile these actually together in a project, and we'll see it work. And we'll use Eclipse for it.
So obviously pencil or Java actually compile first to compile create pencil.
If you were not compiling anything at all, and you were starting fresh, all you have to do is compile create pencil, and it will automatically compile pencil for you, automatically. Because it knows it needs it inside of it. It'll look for it. If it can't find it, it'll go, hey, wait a minute, where's this pencil thing you're talking about? It probably won't say it that friendly, but it'll say something else, and then it'll give you an error. If not, it goes and finds it and compiles it. So here's what ends up happening. You wrote pencil 5 years ago, maybe. And pencil's sitting around, and it's in the directory that you're using for your library files, let's say. And then you already have it compiled, and it's a .class. And then today, you wrote create pencil. It'll go back and it'll look at the precompiled .class and use it as is. So once you create it, you put it in the repository, you keep it in there, and anytime you want to use a pencil, you use it. You go pencil P1 is equal to new pencil. And there's no reinvention. You don't have to rewrite the code. You don't have to recompile anything. It's already in there for you. So this is what people do, and this is why people like Java. You build this huge application. You just change one file. No problem. You just upload one file into there, and the whole application works like it did before. No problem. You build it in C++, you got to take all the build files, all the object code, recompile this one executable file that's running the entire program, and it doesn't automatically get updated like that. So it ends up happening in some of the Java development environments, especially for Android actually too. Separate it all out. So you're in charge of pencils, you're in charge of pens, and you're in charge of erasers. All three of you work on your own code. And then you put it in the same directory on the network, and somebody else is writing this create pencil program, and they're making instances of the erasers and the pens and the pencils, and it works. Well, given that you guys have finished your job, hopefully, and you've put it in there. And then once it's compiled, you can move on to something else, and your .class file is still in there, and it still gets used by anybody else who wants to create a pencil or a pen or an object. It creates reuse in the program. And I haven't gone through my description of object orientation yet, but that's one of the features of reuse. So
with this example, actually, another question
yes?
is like there is an individual developer that are developing their classes, and that those classes can be used by any other person.
Anybody you want.
Yeah. So I don't know who is referencing my class. If I make changes to my class, am I supposed to communicate with that person?
Here's the trick. Because of the public-private protected access methods, you're creating what's called a public interface, which is kind of like the contract. So you're creating a pencil, you're creating a pen, she's got an eraser over there. And you tell me, oh, there's going to be a method to get pencil, set color, and you give me a list of these public methods. I use these public methods in my class. You could change the implementation all you want. You could have 10 different versions of your pencil, and he only has one version of pen, and she's got 2 versions of eraser. And she keeps swapping them in and out, but you leave the public interface the same, it works. Which is why they call it a public interface. And it's really just documenting the contract, or the contract, it was just essentially the interface, which is a list of public methods. So the first thing that Java people do is they go, oh, well, we have this string. Let's make a string space my string equals new string. Okay, what methods are there? I don't know. So you go online and you look at it, you see the contract. You see the public methods. So string has, I don't know, set length, get length. It has a bunch of methods associated with it. That never changes. But the implementation of the Spring class could change. And that could be totally different code that's updated, that's fixed. Oh, there's an error in there. Oh, no problem, fix the error. Put it back in the library, or in the directory, in the package. And as long as you don't change the public interface, the class survives for 20, 30 years, however much length you can actually use it. Which is also familiar, it's also creating a reuse kind of component as well. So, my ears are popping, hold on. I'm getting feedback right now from this mic. All right, so I hopefully answered your question. Okay, good. So I'm going to get into a little bit of a brief diatribe here on object orientation, which is not too brief. It's short. I'll make it short and sweet. Object orientation can be defined in one acronym. Those people like acronyms. It's a pie. So it's A space P-I-E, like the pie, piece of pie that you eat, which are all of the characteristics that are associated with this development environment. So A stands for abstraction. Abstraction comes from the creation of the object, and the abstract, making the entire world nothing more than a composition of objects and objects interacting with each other. You also have data abstraction as a concept that mixes in there. You have polymorphism, which is what the P stands for in a pie. That works with the ability of an object to adapt to its environment, to change, so that a print object can print an integer or can print a float or a double or something. It doesn't always have to print the same thing, depending upon what input it gets, which we build into our classes. So we make the class polymorphic so that we can have multiple constructors and multiple different ways of making these instances and multiple different ways of using them, which also promotes reuse, which is where I remembered this. I haven't talked about this yet. Then we have the I in inheritance. We won't see inheritance till tomorrow, but these classes, if we build them correctly, turn into base classes, and then we build other classes that inherit these classes so we don't have to rewrite anything. Once we have pencil, we can build that highlighter pencil or that other type of pencil. And it builds a hierarchy, and it's called inheritance, where we have, as humans, if you think about evolution, we have inherited things, and we've warped and changed. We don't have tails anymore. We stand upright. If you follow all that, I don't know what it is, the animal monkey theory, Planet of the Apes or whatever. Long story short, through inheritance, we've specialized, we've customized, we've become more intelligent. Well, so does our program, and so does our classes that we're inheriting from that. The E stands for encapsulation, which we're also looking at in this example too. Down here in the main program, which is create pencil, I don't know what's inside of pencil. I am using it. So encapsulation takes the entire concept of the pencil and calls it pencil. A classic example of encapsulation is how we describe our cars. So someone said, well, what's in your car? Well, unless you're, who's that guy in Big Bang Theory? Who? Sheldon. Unless you're Sheldon. Sheldon's going to tell you he's not going to use very much encapsulation. He's going to go through, well, I got a fuel pump, a water pump, a radiator. I don't even know the parts. Bad example for me. If I were answering that question, and I'm not really a Sheldon type, I'd say, well, I got an engine, and then I've just covered hours of Sheldon's explanation. I've encapsulated the concept of all those little components, and I put them into a title. I'm calling it an engine. So if I want to build a car, I say, hey, we'll put an engine in there, put some doors on there, put a roof on there, which is what we're doing in object orientation. So once we figure out we have a pencil available to us, hey, give me a pencil, put a pencil in there. Okay, give me a pen, give me an eraser. I stick all the stuff in my main program. I don't have to worry about how it's implemented. All I have to know is what's its public interface, aka what methods do I have? And that's given to me, and the methods never change. So the methods are your contract. And it says, you know, once you have a get pencil, a set pencil, I'm going to get to that after lunch, then we know we can run that, and we know it's always going to work. So it's kind of like turn engine on, turn engine off. Everybody's car, when you turn it on, does something different. But you turn it on and you turn it off. Everybody's key is different. But it's encapsulated into a key concept. So a PI kind of describes all of object orientation all into one acronym. And it kind of, all the pieces of all of the different components kind of mix and mingle, actually, in the concept. But anyway, I was trying to make that short. So down here at the bottom, this line of code is bad because we made this private. So we can't actually change price. So what we would normally do, if we were writing this correctly, and we'll do this after lunch, is we have what's called accessors and modifiers. I call them setters and getters, and I've mentioned that a couple of times already. So for each one of these things in here, for the variables, I'd have a set this variable, get this variable. What does that mean? It means get the variable is return it to me, tell me what value it's storing, and then set it means assign a value to it. So instead of setting them automatically by going, p1.price is equal to something, then in that particular case, we have no protection. We could just set it to anything we want. But what if there's rules associated with that? If I use a set price and I create this full method that's going to put some rules in here and make sure that I'm setting it to the right price, then my class itself has a higher level of integrity to it. It's kind of like having a date class. And in the date class, you're allowed to set the day of the week or the day of the month. And you set it to 40. I don't know of any months that have 40 days in them. So the integrity of the date, you get this date that shows up to the screen that says, March 40th. Okay, I don't know what date that is. It doesn't make any logical sense. So in the date class, you'd go set month, set year, set day. And in there, there'd be a check to say, is it between 1 and 31? Okay, then, okay, or whatever rules happen to be for that particular month, for that particular day. And you build that into the method so that the methods are stronger. Fewer errors, fewer problems. People aren't going to misuse the class. Set dates that don't make sense. Use pencils as pens instead of pencils or something. So builds integrity into the concept. Another thing I forgot to point out for brand new people is the dot notation. So we always, when we make a reference, this is called a reference. The data type is a pencil. We're referring to it as P1. So we get it, both this data and the methods all in the same way. We say P1.price, and this is called dot notation for newbies. It's dot because you're using a dot. Don't put a colon in there. Don't put 2 colons in there. That's C++ stuff, and that's scope resolution. The dot just says price, which means price inside of P1. So I can make pencil P2, which we'll do after lunch, and then we can go P1.price is equal to this, if this was public, that is. P2.price is equal to something else. And then we have 2 separate pieces of data that are stored for 2 separate instances of the same object type, but there are 2 different references to it. So that's why they call this a reference, because it's referring to an object of this type, and we can set the data. We also run the methods the same way. So instead of saying P1.price, we could say P1.setPrice, and then set price, and then give it a price to set it to. And I'll show you the syntax for calling methods after lunch as well. So. Static. I mentioned it before, and I'm kind of trying to wind down to lunch actually because I'm looking at my clock right now. Static says that only one copy of the static field exists, and it's shared among all the different objects in the class. I don't really like that definition. Instead, I like the definition of the differences between instance variables and class level variables. So we saw here before a P1.price and a P2.price, P3.price, or whatever references we create. These are all separate variables. They're all separate references. They all have separate prices. So those are called instance level. If we want to set one for all pencils, that's where the static comes into place, and that's where we get the class level variable versus the instance level variable. Rarely used, but it does come in handy for sequences, for checkbook sequences. Let's say we want to have a transaction 1, transaction 2, transaction 3. ATM machines, everybody has a different printout of a different transaction number, receipt numbers, Tons of applications have this in there. And calling something static, up here at the top here where we have static in the example here, allows us to make next ID visible to all instances. So P1, P2, P3 all has the same value of next ID. And it all works with it. One change by one instance changes it for everybody else, actually. And we can have static methods that change static variables as well, which is more commonly seen. So you can access directly by the class itself. So you can go pencil, which is a class name, not an object name, dot next ID. So this is a way of looking at, and this is the odd thing, you'll never see this in code. Usually you'll see pencil P1, pencil P2, P1.nextID, P2.nextID. Here it says pencil, we're looking at, well, this is the class here. So it's kind of odd to look at it. And I'm going to go through system I/O when we get when we start after lunch, but because I want to be able to do this with the compiler. But essentially, this is output. It's like printf or cin, cout, printf, scanf, and then in Java we have system out and we have system in. And this is an object type. We know that because it's capitalized. And we know we're running methods on this object. One is out, we have in, and from out we have print line. Well, what does that mean? Well, inside of a method or inside of another object, we have another object, and inside of that object we have another object, and inside of that object there's another object. So we have this hierarchy of dots, which takes a little bit of time to get used to if you're not used to object orientation. But that's what that is about as well. So I think that this is a good time to take our lunch break, actually, because what I want to do when we come back from lunch is to load this up into Eclipse and compile it and run it, and then start playing around with it and make some new variables and really get comfortable with the concept of putting the pieces together with source code and actually writing it, because that's how you're going to learn it. So we're going to take a lunch break, and during the lunch break I'm going to hang out here. I brought my food with me, so I'm going to hang out here and help you if you have problems with the installation. If you got stuck, if it's not downloaded yet, we'll fix those problems so that everybody's up and running when the break is over. How long of a lunch do we want? Actually, here, let me stop this video.